Bienvenidos, Ushamdeed, and welcome to this NetAcad Introduction to Python course supplemental video tutorial. This is the last and final supplemental video tutorial that deals with sections 1, 2, 3, and 4. And this is going to be the final video. We're going to be putting it all together with our Tic-Tac-Toe game. And so let's go ahead and jump over here to the Integrated Development Learning Environment, or IDLE. And we've now defined and successfully put together all of the functions that we're going to be using. Now, remember, as I stated a few times, we put the functions together in a way that would allow us to test the functions and to get them working. But now we've got to pull everything together. So here is our from random import ran range statement that we had. There's the display board function, the inner move function, the make list of free fields function, our victory function, and this is going to be changing significantly here. And then our draw move function, which is when the computer goes. Now, remember where we left off yesterday? I said, okay, well, that is going to be enough to get us through one series of moves, and then we'd have to have 2, and then 3, and so forth and so on. Well, remember, I said that what we would do is we would want this to loop. And typically when you find yourself writing the same code over and over and over again, in sort of a series like we're having to have happen here, and we're invoking these functions one after the other, we would typically drop this into a loop, and this is a great opportunity to do that. So let's clean this code up first here. Let's get rid of all of these sort of move blocks of code, and we're going to bring it back to right here. And so this is where the cleanup is going to begin. So here is the definition of the list, the multi-dimensional or two-dimensional list where we have board defined, right? And this is the start of our game where X is going to be in the spot 5. Now, the number of moves is going to become important because I'm going to deal with the cat's game or the tie by checking to see the number of moves we have. And in fact, we're going to be using the while else construct. And this is typically a question that comes up throughout the course is, can you think of a use case where the while else is going to be something that you would use? And again, typically you would just use the while and then let whatever is going to happen outside of the while loop happen. However, here we're going to use a while else. And so number of moves is going to be set to 1 because 1 move has already been made. We already talked about the human and the computer. And the reason I've got these here is we're going to be adjusting that checking for winner function. And we're going to use a little if else statement in there so that we can check to see if we're congratulating, if it is the human that wins that we're checking for or the computer that wins, we can go ahead and print out the correct message. So let's go ahead and start here, and I'll leave that little block down there because we're going to kind of play off of that block as we move on throughout the tutorial here. So let's go ahead and let's first print a hello and welcome to Tic-Tac-Toe, and let's say the Pythonic way. All right, so there's sort of the first thing that's going to happen when this program runs. We're going to be printing out hello and welcome to Tic-Tac-Toe the Pythonic way. And then let me go ahead and we'll say print, here is the current status of our game board. Right, and then we have that print statement there, and so then I'm going to call the display board, and we're passing it board. And at this point, what we should see is the board would be displayed to us with the X in the middle spot. And then after that gets displayed, I'm going to put just a empty print statement, which is going to give me a new line. And it's just going to give me a break in between some of the other things I'm going to do. And so right now, right, this is the start of our program right here. Now, this is where we're going to jump into the while loop, and I'm going to say number of moves less than 9. And this is, I could say less than or equal to 9, and then do an if statement in the while loop. But I like the while else here because it's an opportunity to use the while else construct, and it also gets rid of an unneeded if number of moves equals 9 statement inside the while loop. So while the number of moves is, less than 9, what are we going to do here? Well, remember, we've displayed the board, so it's going to be the user's turn, right? It's going to be the user's turn. So we would want to say enter move. And oops, sorry, we're going to pass in the board, right? So that is going to come up to the enter move function, right? And this is what we're calling here. And so this is going to say, please input within the range of squares. And again, we've already tested this code out, so we're good to go here. And I like this the way we've got it, right? And I really like the nested for loop that we have here to go through and check to see if the move is, or I should say, if the square in the board is already taken, right? So very concise there. And then, well, let me check something out here. Enter move, and then we break out. Oh, right. Yeah, so we break. What we could do instead of the break is I could just return out, but we'll break out of that, and that's going to get us out of the loop and take us out of there anyway. So we'll stick with enter move board, and then what we're going to do is after the user has gone, right, the user has entered a move, number of moves is going to be incremented by 1. Right? And if you think about it, it makes sense. The user just went, so we now have 2 moves have been made. Now, we haven't redisplayed the board, so we want to go ahead and say display board, because that right there is the user's turn. The user makes their move. We call that function enter move. We make sure that it's an open square, that it's a square that's not already taken. We enter the O into that square. We then increment the number of moves because now there have been 2 total moves made. And then we want to display the board back out. Now, once the user has gone, what we could get tricky here. And if you think about it, excuse me, the minimal number of moves that would have to take place in this game for the user to win would be, we've got X to start with, so that's 1. The user goes, that's 2. Then the computer would go, that would be 3. The user would go again, it would be 4. The computer would go, it would be 5. And then the user would have to go, it's on the 6th. So it's not until the number of moves equals 6 that we should even be checking to see if there's a victory for the human. But again, it didn't want us to do that, but that's something to think about, right? And what we could check, and what we would be checking right here is we would be saying if number of moves is, let's say it would be, let's say greater than or equal to, so we'll do greater than or equal to 6, right? Because the number of moves at a minimum for the human to win the game would have to be 6. But I'm not going to drop that in there right now. We'll just leave that out. But that's what you'd be checking on. And then you would do sort of the following. And here's where we're going to check. We're going to say if victory, and what did I do? 4. And then we'll say board. I'm looking down below here to check, see what I'm doing. So if the victory for the human is true, then we're going to print, and let's say you crushed the computer. You are a super human. Woot woot. All right, so there we go. So that's the message. If any of the checks that we have that would return true which would be any of the victory checks, the 8 combinations that we have there. And again, we're going to have to go back up there here in just a second. Because again, remember, we initially set it up so we could see what was happening, but now we're going to be passing in, or I should say we're going to be asking for status to be returned as true or not. Now, if there's a winner, we break. We're out of the loop, right? We're going to come right out of that loop. Now, here's the else that we're going to have set up here. So we check to see if the if the human was the winner. Again, we're still kind of dealing with the human moving here. But if it's not, we're going to go ahead and say print. Here is the current list of free squares on our board and the status. So let's do that. Now, again, remember, we've got a couple things we're going to have to change here. So let me stop right now before we get too far beyond the changes. So again, remember what we're looking for here is if victory for that function, when we invoke that function, if it returned true. Well, let's come up here and take a look. Right now, you can see it's not checking, or it's not returning anything. And so what we would need to do, and actually let me just grab the line here and we'll do this, is if it's in fact a winner, right? If that combination 000102, for whatever the sign is, right? If that is correct, we've got a winner. We want to return true. And so again, we'll have to do this 8 times. So hang with me here and let's clean this up. And again, those print statements were in there for us to do some testing initially with the algorithm just to ensure that the, oops, not K return, so we'll say return true. Testing the algorithm to make sure that the algorithm actually functioned. And again, now we're going to fine tune things here. We're going to say return true there. We're going to come back here, return true here. We've got 2 more to go. Again, we'll make sure we clean this up. Return true. And then we'll come down here and we'll say return true. All right. So for the time being, we're going to go ahead and leave the else statement here. And you can see we've got this print statement checking to see if player, and then we look at the sign, is the winner. Now, we're going to be fixing this, or I should say we're going to be adjusting that as well. But we've taken care of the returning true for any combination that, in fact, would return true for if there's a victory. And so for the human move, right, and again, this is the human move we're checking. We don't have to check the computer move first because the computer only has a single X on the board and can't win. All right, so you're a superhuman, woot woot, break, print. Okay, here's a current list. And so else is if it's not true, right? If it doesn't return true, that would mean that we don't have, the human hasn't won the game yet. So we would come to the else statement and we would print out, here's a current list of the squares on the board and their status. And let's go ahead and to get that, we're going to have to call that make list of free fields. And we pass in the board, B-O-A-R-D. All right. And I'm going to put a blank line in between there. We'll try to make this look a little bit nice. And then we'll say display board, right? And board. So at this point, that's going to do it for the user's turn, right? That's going to do it for the user's turn. And in fact, I could even drop a little comment in here that says the following code covers the user's turn each round. All right. And so there's the user's turn each round. So we'll come back out here. Let's drop back out there. Okay, so we're good there. And let's do this. Do I put the display? So no, here's what I'll do. I'll put a blank line here, right? So after the user's turn, now it's going to be time for the computer to go. So let's print that up. Now it is time for the computer to make its move, All right. So we're going to print that statement. And now what are we going to do? Well, we're going to invoke or call the draw move function that we did in the previous video. And we're going to give that a call because it's auto-magically, randomly going to go in there and check for an open square, a square that's not taken yet, and it's going to go ahead and put the computer's move in that square. So once the computer moves, number of moves is going to be incremented by 1. And then if I was to go back up here, let's see, draw move. Do we print the board up here? We do not print the board up there. And I'm debating here. Yeah, we'll display the board. Yeah, we'd want to display the board here. So this is what I'll say. We'll say display board to show the computer move, right? So the computer goes, randomly selects any of the available squares. We increment the number of moves because now the computer is gone, so that counts as a move. And then we're going to display the board after the computer moves. And then I always like to keep a blank line, right, separating the board from what we're going to be doing next. So let me scoot up just a little bit here, and I can grab this code right here, or I should say this comment right here. We'll do a quick copy and paste. Whoops. Sorry about that. Hold on one second. Lost it there. Do a quick copy and paste here. And this is going to be the computer's turn. Computer's turn each round. All right, so we've got that print to break things up. And actually, I'm going to be good here. I think we've already done display board, make a list of free. We've checked for the victory for the human, so let's pull all that out of here. So now, if we're sort of going along with the same thought process, after the computer goes, right? Again, we could skip it if it was less than 6, which would be the minimal number, or I should say with the computer, it would be 5, because the computer's already gone first. But we're going to go ahead and leave that the way it is. So if victory 4, board, and then I think I said here computer, that's going to pass in the capital X, is true, right? And the code is going to be almost identical to the code that we had up top, right? So I would print in here, the computer has outsmarted you once again, human. Better luck next time. All right. And so that's going to be, if in fact it returns true for the computer, that's what we're going to say, and then we're out of the program, right? We're out of the while loop, I should say. We're going to be out of that while loop. Now, what if that's not the case? Well, if it's not the case, we want to literally, oops, sorry, didn't mean to make it bounce like that. We're going to grab this code here, right? Say Control-C, a little code reuse here, and we're going to drop that in here. So I'd say here's a current list of the free squares on our board and the status, and I'm going to make a list of the free fields, and let's see. So we'll make a list of the free fields and put a blank line in there after the free fields. And let me think this through here real quick. So we're going to say make a list of the free fields. And you know what? We don't need... And we're not displaying. I'm just trying to figure out if we're going to display it too many times, because it's going to be displayed there. But I guess if we want to stick, and we'll run it through like this, and we'll see what happens. So we'll keep the same code as we have in the else statement above, and then we'll see what happens. All right. And so for all intents and purposes, we would think that that would be it. But remember, if we're going to print out here is a list of the free squares on our board and the status, we don't need, let's go back up here. So first of all, I don't need to say that, and that's what we wanted to do. I wanted to check. So we're going to make a small modification in this function here. So let's do this. Yeah, so I'm going to make a small modification here. We're not going to print that out because we know that, so if the sign is a capital O, oops, sorry. If the sign is a capital O, I'm going to print, and this is where we'll go ahead and print, and we'll say, checking to see if you are the winner, right? And that would be whoever's playing the game. And if it's not you, I don't have to, what am I trying to say? I don't have to check to see, and that actually dropped it back there. Hold on one second here. I don't actually have to check for the capital X, right? That's something I don't need to do. I can simply say else, because if it's not a capital O that got passed in as the sign, we know that it's going to be the capital X, and then I would just simply say print checking to see if the computer has has won the game. Right? And so we'll leave it like that. And so this little if statement right in here, inside this function victory4, is checking to see the positional parameter sign that gets passed in. It's checking to see, is it a capital O? Because if it is, and that's who I'm checking to see has won the game, and remember the sign that we're passing in down here under the human bit of code, right? When we pass in the argument, we pass the argument, which is here, human is the capital O. Computer would be the capital X. And so we're going to deal with the if, to determine who it is we're checking on here. Let's go back up a little bit. Sorry, wrong way. To see who we're checking for here, we're going to use the if to make that check. And then let's make sure in the free squares I wanted to check to see. So we've got the free squares. We're going to go ahead and leave the global, and I think we're good here printing the free squares. And I think we might be good to wrap this up. And so again, the number of moves. And so here's my thinking behind this while the number of moves is less than 9. Because if the number of moves is 9, we would have come in here when the number of moves was 8. Now, either the human goes, and I guess it would always be the computer that goes last, I believe, and we'll see it in just a second. But that would increment the number of moves to 9, and it's going to then check to see, did the computer win? So if the computer goes last, when we enter this while loop, and the value of number of moves is 8, and the computer is who is going last, right? And the computer goes, and we increment the number of moves to 9. But we don't have a winner here, right? There's no winner, and we don't break. And then we hit the else. We're just going to continue back up for another iteration through the loop. But at that point, it would be 9, meaning we had no winner. So therefore, if it is the number of moves equal to 9, which it would be if that was false, then what we would say or could say down here is else, and then we can drop in a, and let's see, what are we going to say if it's going to be a tie? So I can have an else statement down here that would just simply say print, and actually let me get rid of all of that. We don't need any of these here. And so we'll clean this up, make it look really nice. All right, so then we're going to end up printing, we have a tie. This is and this is interesting. The cat's, oops, sorry, I got to escape that there. The cat's game, right? Why do they call it a cat's game? So and apparently cats can't scratch their own tails. And so that is the origin of this. It's a cat's game when it's a tie in tic-tac-toe, meaning no one can win, just like a cat cannot scratch its own tail, which I don't know. I find that hard to believe that a cat can't scratch its own tail, but I'll go with it. So that is going to be the while. If the while fails. The test for the while fails, meaning it's no longer less than 9. We're going to print out we've got a cats game, meaning it's equal to 9. Now, the final print that I'm going to put down here, which is outside of the while loop, and it's going to execute as the last line of code. Let's go ahead and say print something like, thank you for playing. Please play again soon. All right, and that's kind of like the parting, thank you so much for playing. Please play again soon. Let me go ahead and take a look at this, and let's go ahead and let's run this code and see what we've got here. So I'm going to hit F5. I'm going to click OK. All right, so here we are on the clean board, and let's go. I'm going to go ahead and try to win the game. So we're going to test all 3 possibilities. I win, the computer wins, or it's a cats game. So I'm going to go for the win here. So I'll pick square 9. And you can see, and I'm going to scroll back up there in just a second here. You can see, checking to see if you're the winner. We do not have a winner yet. Here's the list of the free squares on the board, right? And that gets printed out. And there is the board that is being displayed. And so now it's time for the computer to make its move. And you can see the computer went right there. And we're checking to see if the computer's now won the game. We don't have a winner yet. Remember, for the user, the human, you would need at least 6 moves. For the computer to win, we would need at least 5 because the computer got to go first. And here are the available squares left on the board. So again, I'm going for the win here, and I got to block the computer. So I'm going to grab spot 6 for the block and hope the computer does not go to 3, which it did not, right? So, and you can see here, our list is shrinking down. So let's come down here. Let's say 3. I'm going to go for the win, and this should terminate the program, right? Checking to see if you are the winner. You crush the computer. You are a superhuman. Woot woot. Thank you for playing. Please play again soon. All right, so it worked when we did it when we won. Let's run it again here, and now let's allow the computer to win. So I'm going to pick square number 2. And again, we've got our free squares. We've got everything being printed up for us here. The computer, okay, so 4 is going to be the winning spot. So I'm going to make sure that I go to number 9. I'm going to go out of the way to hopefully force the computer to win, and I just block the computer. So I'll do spot 3, and hopefully the computer does not take 8. And it took, of course it took 8. All right, so I'm going to do 7, and the computer does go last every time. So I'm going to do 7, meaning the computer is going to win here. So we enter the while loop, and we have 8. Number of moves would be 8. The computer's going to go here, but remember, checking to see if the computer has won the game. The computer has outsmarted you once again. And I should probably check to see if outsmarted is 1 or 2 words. I think it's 1 word. Better luck next time. Thank you for playing. Please play again soon. So you'll notice that it doesn't, when it enters as 8, right, and the move is made, number of moves is incremented, but we never get back to the next iteration because we're checking to see if the computer has won first. And it did. All right, let's come back over here. Let's hit F5 one last time. And this is probably the most difficult. And that is the cats game, to force the cats game. So I'm going to go with number 2. And we're probably going to have to block right away. And we do. And so I'm going to go to number 3. And now I want to hope that the computer goes to number 1 randomly. It did not there. That's okay. I'm going to go to 8 for the block and hope the computer doesn't go to 1. And thank goodness it didn't, but now I'm in even worse shape. This is not going to be a cats game because if I go to 1, the computer has to go to 4. If I go to 4, the computer has to go to 1. Both of those will be wins for the computer. And there we go. The computer won. Or I'm sorry, I chose 1. Did I choose 1? I did. So I took the win away from the computer. So let's do F5 one more time here to see if we can force a cats game. I'll say, oops, sorry. And we're going to have to start again here. Let me hit F5. And that happens sometimes when, if I clicked up here and then hit something, we get some odd output there. So we'll say 9, and we'll see where the computer goes here. All right, good. So now I'm off for the block at number 4, and it doesn't line me up for a win, which is exactly what we want. All right, good. So now I'm going to go to 7, and let's hope the computer goes to 8 for the block. And it didn't, but that's okay, because now, as you can see on the board here, I'm going to take number 2. It's going to steal the win, but it's not going to give me the win. Steals the win from the computer, and it forces the computer, who always goes first and last, to take 8, which means we should have a cat's game. It should be a tie. So I'm going to take 2, and let's see if this code works out here. And here we go. We don't have a winner yet. The current list of squares. So again, there's no winner. We have a tie. This is a cat's game. Thank you for playing. Please play again soon. All right. Well, I first of all want to thank you for sticking with me, and again, apologize. You know, I went on vacation. I had all of the best intentions to get this done before I left out for a quick family vacation. But we are finished. And so here is sort of the bottom part of the code. We declare our global variables. We have a greeting to open things up. We display the board, and then we go right into our while loop. We have the user make their move. The computer's already gone. We display the board. We check for a victory. And then we go into the computer's code, right? Or the computer's move, I should say. And then we check for a victory, displaying the board as we go and making sure we're incrementing the number of moves. Some of the minor changes that we made were here. Instead of a print statement, which is what we were using for testing, we want to return true because that's what we're testing for. And if none of those is true, then, well, we do not have a winner yet. And at the very beginning of the victory for function, I just threw a quick if statement in here so that it can handle whatever the positional parameter value is. Based on that value, we would be able to say if we're checking to see if you, the human, won the game, or if we're checking to see if the computer won the game. And then based off the return value, right, if we do have a winner, it would come back as true. Then we would go ahead and break out. After we had checked for the victory, we would print out that either the computer won or you won, and then we would break out of that loop, kicking us all the way out here to thank you for playing. And again, the cat's game, I just used a simple counter to keep track of the number of moves. Now, I'm pretty sure we met all the requirements for the game. We've got all 5 functions in there, and we've got a pretty cool little program if we ever wanted to play Tic-Tac-Toe. So again, I thank you so much for watching. I wish you the best of luck in your studies, and I hope to see you in another upcoming video where we're now jumping into Module 5 and Module 6. So thanks a bunch, have a great day, and best of luck to you out there on the wire. See you soon.